Okay, we're going to start working on distance problems. And the first thing I want to do before we even look at a problem is to look at the kinds of distance problems we're going to deal with. Distance, first of all, understand, has a formula. Distance equals rate times time. If you take your car and you drive at 60 miles an hour for 3 hours, how far have you driven? Yeah, we do this every day, don't we? 60 times 3 is 180 miles. This is something we calculate when we travel or go anywhere. We go, well, if I drive 70 miles an hour, how far will I go in 3 hours? If I'm going a 2,000-mile trip, that's a pretty important thing to know how long it's going to take you to do this. So this is a really good tool to know that formula. Distance equals rate times time. Rate is how fast you're going. Time is how many hours have elapsed. So there we are. So now let's look at the 3 kinds of problems we're going to deal with here in 30 Math. The first kind of problem is dealing with starting from the same point, such as a town. One vehicle is going to go one direction, the other vehicle is going to go the other direction. And you're going to end up with a total mileage, a total distance here. So what kind of a formula is that one going to give? If you think about it, it's this distance plus this distance. So distance of the vehicle number 1 plus the distance of vehicle number 2 is going to yield your total distance. Okay? That's what it's going to be. And remember, those distances of these vehicles is made up of the rate times the time. Now, let's look at the second one. This one, we start at towns far apart. And again, you're looking at that total distance as part of the equation, but they're going to meet in the middle. And we want to know, most of the time, how long it takes them to meet in the middle. So again, you're looking at the distance of number 1 and the distance of number 2. And they're going to add to get to that middle point. So your distance of number 1 plus the distance of number 2 is going to equal your total distance. As you can see, although the equations are set up differently, in actuality, the pictures are different, but in actuality, your equation is the same thing. You're adding 2 distances together to get the third distance. Now, our third kind of problem is very different from the first 2, because we're going to look at the distance of number 1 and also the distance of number 2. But notice, even though they leave at the same time, one is going faster than the other one, so it goes farther. And we're going to want to know how long it's going to take them to get a certain distance in between them. So this is a difference of the 2 differences. So it's not a total distance now, it's a difference of the distances, because the one that went farther subtracts the one who went less. Now, there's more than this way to work these out, I will admit, but I'm showing you the basic algebraic way to do this. So we're going to look at this one. Which one went farther? Yeah, number 2 did. So this one is going to end up with distance of number 2 minus distance of number 1 is going to equal your final amount. Okay? Those are the 3 kinds of problems that we are going to deal with in distance. Now, we're going to do each one from each of these types, and I'm going to ask you to identify, is it going from one town away from each other? So is it a sum? Are they going towards each other? So that one's a sum. Or are they taking off from the same place but going one farther than the first? So you're looking at the distance between the 2. Okay?